All right, special right triangles. So the point of this video is so that we can calculate the sine, the cosine, and the tangent of 30, 60, and 45. So let's just define what some special right triangle values are. Special right triangles can be a 30, 60, 90 right triangle. Or it can be a 45, 45, 90 right triangle. So these are the two special right triangles, and we're going to try to develop how we can come up with the sine of 30, the sine of 60, the sine of 45, the cosine of 30, the cosine of 60, the cosine of 45, and then use sine and cosine values to determine tangent of 30, tangent of 60, and tangent of 45. So let's start with the 30, 60, 90. In order to create a 30, 60, 90 right triangle, let's set up an equilateral triangle. Remember that the equilateral triangle, we're working off of the unit circle. So we have an equilateral triangle in which all of the sides are 1. Another property of equilateral triangles is that all of the angles are 60. Okay, let's drop a perpendicular bisector, which bisects the angle and the side, because it serves as a median to the triangle. So now if this whole line was 1, we just cut this in half, and now we have 1/2 as each of these sides. Also, we cut this angle in half, making a pair of 30, 60, 90 right triangles. So now we can find the height of this triangle using the Pythagorean theorem. So I'm going to group this all together and move it to the side. Group, group, and we're going to use the Pythagorean theorem to solve for this height. Okay, so we're using one of these triangles now, which now we have the special right triangle 30, 60, 90, in which we have two sides. So a squared plus b squared equals c squared, not x squared equals x squared plus 1/2 squared equals 1 squared. X squared plus 1/4 equals 1. Let's subtract 1/4 from both sides, which means we're subtracting 1/4 from 4 quarters, giving you x squared equals 3/4. Let's take the square root of both sides, and we'll only focus on the principal square root because obviously a distance cannot be negative. Square root of both sides, x equals the square root of 3/2. So now we know what this line segment is. It's radical 3/2. So now I'm going to draw this triangle again, and we're going to calculate the sine of 30, the sine of 60, the cosine of 30, the cosine of 60, and then we're going to find out tangent values using sine and cosine. So I'm going to redraw that triangle, but now we are only looking at one of them. So we had a base of 1/2, hypotenuse of 1, and another leg of radical 3/2. This was your 60-degree angle, and this was your 30-degree angle. So let's calculate the sine of 30, the sine of 60, the cosine of 30, the cosine of 60. Remember that sine is opposite over hypotenuse, so if we're working with 30 degrees, this is the angle we're talking about. The opposite is 1/2, and the hypotenuse is 1. Therefore, sine of 30 is 1/2. Sine of 60, well, sine is opposite over hypotenuse. Now we're talking about the 60-degree angle. Notice we're changing sides of the triangle now. The opposite now is over here. Opposite over hypotenuse is radical 3/2. The cosine of 30, now we're talking about adjacent over hypotenuse. We're talking about the 30-degree angle. Adjacent is radical 3/2, and hypotenuse is 1. Radical 3/2. The cosine of 60, again, is adjacent over hypotenuse. Now we're discussing the 60-degree angle. Adjacent is 1/2, and hypotenuse is 1. So these are special right triangle values for the angles 30 and 60. So these are values that you really have to be familiar with. And the way I like to remember it is if you know that the sine of 30 is a half, you kind of develop everything else on your own. And just recall where this all came from. This came from a triangle here. And now, if you're talking about sine of 30 and sine of 60, the opposite is two different sides of a triangle. No sides of this triangle is the same. So if you know that the sine of 30 is a half, well then the sine of 60 can't be a half. The sine of 60 is radical 3 over 2. If you know that the sine of 30 is a half, then the cosine of 30 can't be a half, because 30 is talking about opposite or adjacent between sine and cosine. So if the sine of 30 is a half, then the cosine of 30 can't be a half, radical 3 over 2. Well, if the sine of 30 is a half, then the cosine of 60 is a half, because the opposite of 30 is the same as the adjacent as 60. So again, starting with the sine of 30 is a half, you should be able to come up with the rest of these special right triangle values. So just try to remember that 1/2 and radical 3 over 2 to kind of work together. And you'll see as we put this on the unit circle how specifically they work together. What we didn't do yet was calculate the tangent of 30 and the tangent of 60. Well, tangent is sine over cosine. So this is equal to the sine of 30 over the cosine of 30. Let's plug in the sine of 30's value, which is a half. And the cosine of 30 is radical 3 over 2. And now we're going to keep change flip to divide these two fractions. So the tangent of 30, 1/2 divided by, get rid of that straight mark there, 1/2 divided by radical 3 over 2, which is 1/2 times 2 over radical 3. So we have canceling 2's, 1 over radical 3. Don't forget to rationalize your denominator. Radical 3 over 3. Tangent values aren't something I memorize. That's something I work out by doing sine over cosine. So now we know that the tangent of 30 is radical 3 over 3. Now let's do the tangent of 60. Well, the tangent of 60 is sine of 60 over cosine of 60. Well, the sine of 60 was radical 3 over 2. And the cosine of 60 is 1/2. We have canceling 2's here, therefore, the tangent of 60 is radical 3. Again, I don't memorize tangent values, I work them out by doing sine over cosine and cleaning up the fraction. Okay, so those are all the special right triangle values for a 30, 60, 90 right triangle. How about a 45, 45, 90 right triangle? That looks isosceles. Let's try a 45, 45, 90 right triangle. Just remember that this comes from the unit circle. So we have a 45, 45, 90 right triangle in which the hypotenuse will be 1. So let's find the value of these sides by using the Pythagorean theorem. X squared plus x squared equals 1 squared. Again, the hypotenuse is 1 because this comes from the unit circle. So we have x squared plus x squared equals 1 squared. X squared plus x squared is 2x squared. Divide by 2. And you get x squared equals 1/2. Take the square root of both sides. X equals the square root of 1, which is 1. The square root of 2, which is the square root of 2. Rationalize your denominator. Radical 2 over 2. Okay? So now we know that these two missing values, which are the same because this is an isosceles triangle, are radical 2 over 2. Okay, so group this all together and throw it aside and calculate the sine and cosine of all this. Group. So let's find the sine of 45, the cosine of 45, and the tangent of 45. Well, the sine of 45 is opposite over hypotenuse, therefore it's radical 2 over 2. The cosine of 45, well, it doesn't matter which 45 you're talking about, the adjacent is radical 2 over 2. But guess what? So is the opposite. Therefore, sine and cosine are the same values at 45 degrees. Tangent of 45 is opposite over adjacent, radical 2 over 2, divided by radical 2 over 2, 1. Okay, so those are all of our special right triangle values. And just to summarize, if you start with the sine of 30 equals a half, then you kind of get all the other 30, 60, 90 right triangle values. Well, if the sine of 30 is a half, then the cosine of 30 cannot be a half. That has to be radical 3 over 2. Well, if the sine of 30 is a half, then the sine of 60 certainly can't be a half. That has to be radical 3 over 2. Well, if the cosine of 60 is radical 3 over 2, then if the sine of 60 is radical 3 over 2, then the cosine of 60 can't be that. That's got to be a half. And then tangent, I'll divide the values. And 45, the sine of 45 is radical 2 over 2, and the cosine of 45 is radical 2 over 2. So those are all of your special right triangle values, in which tangent you can find by calculating sine over cosine.